Okay, for this screencast, we're going to do something called bilinear interpolation. So I'm just going to call it interp2, my interp2. And basically what you need, and I already did this problem I had before, is you need an x, a y coordinate, and a z coordinate. So I'm going to copy this. Ooh, that did not work. Let's see. Copy. Paste. Okay, so basically what I did was I created an x vector, so that goes from minus pi to pi, and then a y vector, which is the same. I make a mesh grid. I make a z coordinate, which is a sum of sine waves, and then I essentially get all this header stuff for plotting, and then I'm going to copy this over here, and I'm going to go ahead and maximize this. And basically what I do is I do two nested for loops through x, x, y, y, and z, z, and I plot a blue star at each one. So when I hit F5 here is my two-dimensional mesh here that essentially is x, y, and z here. So the question is what if I want to grab the z coordinate, say here, or here, or here, somewhere in between these two data sets. So what you need to do is do two-dimensional interpolation. So basically, over here I have on Sakai, here is a sort of a snapshot of what we're doing. So I assume I have these four data points. I have z00, z10, z11, and z01. And what I do is I do a single interpolation along this axis to get z lower, and then a single interpolation along this axis to get z upper, and then an interpolation along this axis to get z star. And what it's going to look like from a top-down view, it's going to look like this, right? So the first thing we need to do is we need to grab our four data points. So what I'm going to do is I'm going to go down here and I'm going to say, okay, well, let's say x star is -2 and y star is, say, 1.5. Okay? So if you watched my linear interpolation video, you should have seen the way to do this is to simply do the find function. So I'm going to do location x is find x star less than x comma 1, and then location y is find x star, or sorry, y star less than y comma 1. And then again, now I can just say x0 is x of location x minus 1, x1 is x of location x, and then y0 is x of loc y minus 1, and y1 is x of loc y. And then now I can grab z00, which is a zz of loc x minus 1, comma loc y minus 1, z10 is zz of loc x, comma loc y minus 1, z01 is zz of loc x minus 1, loc y, and z11 is zz of loc x, comma loc y. And then what I want to do is I want to plot all these guys. So I'm going to do plot 3 x0, y0, z00, and I'm going to do a green circle. So I'm just going to circle the data point that I have, size, comma 10, and then I'm just going to copy and paste this 4 times, and then I'm going to change this to x1, z1, and then y1, z01, and then x1, y1, z11, and then now I should have, there we go. So now at -2 along x and 1 point following on y, here are my 4 data points. So if I make like a 3D mesh here, there are my 4 data points that I'm going to interpolate between. So now we just do the 3 interpolations. So if we go back to our equation here, I'm going to put this guy over here on the right and this guy over here on the left. And so basically we have z upper is, and then that's the function evaluated at x0, y1, so that's z01, is plus, and then the function evaluated at x1, y1, so that's z11 minus, and then I'm going to, I guess I can't scoot this over, so it's z11 minus z01 minus z01 divided by, and then it's x1 minus x1 minus x0 times x star minus x0. Now if you look at the equation down here, it's the same thing, except now you change all of your y1s to y0s. So then I have z lower is z00 plus z10 minus z00 divided by x1 minus x0 times x star minus x0. And then what I'm going to do here is I'm going to plot these real quick just so you can see them. So I'm going to plot x0. I'm going to plot x star, comma y0, comma z lower. I'm going to plot a red star there. And then I'm going to do plot x star y1, comma z upper, red star, and I'm going to do a marker size of 10. Okay, let's see, it looks like I got an error. Let's put this over here. Unknown, okay, because I keep doing plot instead of plot 3. There we go. So there's my interpolation along x. So if we go back to Sakai, yeah, that's fine. I'll do it this way. So basically, here are my green data points, and then here are my two reds where I'm interpolating along the upper and the lower, and then essentially I'm interpolating along these two axes. And now you just interpolate along this last axis, and you get this guy. So then that's just z star equals z lower plus z upper minus z lower divided by y1 minus y0 times y star. So let's code that real fast. So we'll get z star equals z lower plus z upper minus z lower divided by y1 minus y0 times y star minus y0, and then let's plot 3 x star, comma y star, comma z star, and then I'll do this in a black star, marker size 10. And there you go. So then there is my z star right in between there, and if we maximize this and do it, you'll see, this is sort of a wonky two-dimensional plate here in between here. And that's essentially how I made this this figure here. But basically, if you wanted to do two-dimensional linear splines, you could do it the same way. You could just make 2D squares that go through the whole system, and you'd have your 2D linear splines. All right. Well, hopefully that helped. Good luck.